Topic 3-3, Part 3. Some algebraic expressions containing exponents include several bases or a combination of numbers and variables. So inspect the expression carefully in order to apply the properties of exponents successfully. Let's look at this first example. 2 times 3 cubed. Again, to cube anything, whatever's inside these parentheses, would mean to write it down and multiply it times itself 3 times. We could also look at this problem as each term individually. We could look at taking just 2 and writing it down 3 times, 2 times 2 times 2, or we could just take and look at it as 3 cubed as 3 times 3 times 3. Notice this step has 3 2's and 3 3's, just like this step has 3 2's and 3 3's. So you end up seeing that each one individually is cubed. 2 is cubed and 3 is cubed. You can also look at it as 2 is being raised to the first power. Every number, every letter has an exponent. If you don't see one, it's understood to be a 1. So you have 2 to the first, and you see that is being cubed. And then you have 3 to the first raised on to a higher power of 3. So remember, when one exponent's inside and one exponent's outside, we multiply them. So we have 1 times 3 gives you 2 cubed, or 1 times 3 also gives you 3 cubed. So you end up, if you multiply these exponents, you still get 2 cubed and 3 cubed, either way you look at it. So let's look at the power of a power rules for 3-3, Part 3. Arithmetic rule says when you're multiplying inside the parentheses raised to a higher power, you will raise each exponent to that higher power. You will raise the base. Remember, 2 is raised to the first power. Multiplied times 3 would give you 2 cubed. 3 is to the first power. Multiplied times 3. 1 times 3 gives you 3 cubed. So algebra formula. When you have several terms inside the parentheses raised to the higher power, each one individually is raised to that higher power. A to the nth, B to the nth, where A is not 0, B is not 0, and N is an integer. So let's look at some examples. Simplifying expressions with multiplication and exponents. Let's simplify each one of these expressions. So I have several terms. This is 3 times C times D. So I'm going to take 3 to the first power and raise it to the second. I'm going to take C to the first power and raise it to the second. And I'm also going to take D to the first power and raise it to the second power. Each one of these multiplied together. When one exponent is inside and one exponent is outside, we have learned to multiply those. Therefore, this would be 3 squared. C raised to the first power, raised on to a higher power of 2, multiply those, you get C squared. D is to the first power, raised on to the higher power, multiply those together, you get D squared. Now, we could continue on with this problem. We could raise 3 to the second power. Well, 3 squared, students, would give me 9. 3 times 3 is 9. And then we write C squared, D squared. So go ahead and raise your integer to the exponent. 3 squared was 3 times 3, which gives you 9. So my answer is 9 C squared, D squared. Let's look at B part. Raising each one to the higher power of 3. 5 is to the first, so I'm going to take 5 to the first and cube it. That means the same thing as me writing down 5 3 times. I'm going to take m squared and cube it, parentheses around it and cube it. And I'm also going to take n squared, parentheses around it and cube it, raising each one to the third power. That's just the same as me writing 5 times itself 3 times, or writing m squared times itself 3 times, and writing n squared times itself 3 times. Well, 5 to the first raised to the third power would give you 5 cubed if you multiply those exponents. Here, if we multiply these, 2 times 3 gives you m to the sixth. N squared to the third. Multiply those, you get n to the sixth. Now, all of this is multiplied together. Now, 5 cubed, that's the same thing as 5 times 5 times 5. That is not 15. This is 5 times 5 is 25, and 25 times 5 gives me 125. M to the sixth, n to the sixth. So your final answer for B part is 125, m to the sixth, n to the sixth.